If x and y are independent variables, with the standard deviation of x is 3 and the standard deviation of y is 4, determine the standard deviation of x minus y. And notice they have said that these variables are independent, so that gives me a few more formulas that I can work with. Because we don't have a whole lot of information. We don't have PDFs or expected values or anything we can do. So we have to rely on formulas. So think, what formulas did we have involving two random variables and standard deviation? Well, we didn't have any. So is this question impossible? No. But we're going to have to go hunting for something else. We don't have a formula for standard deviation of x's and y's. I know sometimes people in a panic will say, oh, well, things are nice when it's independent, so it'll split. Or maybe it's similar to what we saw with the variance, and it goes like that. No. Unless you know there's a formula, don't make one up. Don't say, well, it should work like that. Okay? Math isn't based around what you think would be nice or what would be easiest to do or what probably is the answer. Math is precise. That's one of the nice things about it. Okay? If you do it right, you'll always do it at the same time. You'll always get the same answer. Okay? Now, if I don't have a formula for standard deviation, what can I do? Well, we know standard deviation is the square root of the variance. And the variance does have some formulas, especially when it comes to two random variables and independence. Remember, you've got ax plus by. The a and the b can sort of pop out at the cost of a square. Okay? Well, how does that help us for x and y? Well, if I let a be 1 and b be negative 1, x minus y is really x plus negative 1y. Okay? And then, well, there's really a 1 there, so the 1 can hop out. 1 squared, variance of x, plus negative 1 squared, variance of y. And when you simplify it, 1 squared and minus 1 squared are just 1. So the variance of x minus y is really the variance of x plus the variance of y. Okay, well, we can take that and use it, the expression we had up above. So we want the standard deviation of x minus y. That's the square root of the variance of x minus y. But because our random variables are independent, that's the only reason that we could use this formula here. It's because we saw in the question that they're independent. You can split it up and say, variance of x plus variance of y. We go back to the question, and we see, they didn't tell us that. But they did tell us the standard deviation of x and the standard deviation of y. And so to get the variance, we just square standard deviation. So we get 3 squared plus 4 squared. That's 9 plus 16. So the standard deviation we want is the square root of 25. And remember, under the square root sign, you always take the positive root. We get 5. So the standard deviation of x minus y is 5. We had to use the relationship between standard deviation and variance twice. And then, because x and y were independent, we were able to sort of fill in the gaps right